In this explainer, we'll be looking at protocols and layers. The goal here is to understand how data is sent, received, and reliably understood by different devices across a network.
Right, let's start with a question to get you thinking. Imagine two classrooms, both using a network. In the first, there are 30 laptops, all connected using Wi-Fi. In the other, there are 30 desktop PCs connected with cables. Now, which of these two setups is likely to give better performance? Take a moment to think about the reasons for your answer.
So, for any network to actually work, all the devices on it must have an agreed way to communicate. This means there needs to be an established set of rules to make sure that communication can happen. But why exactly are these rules so important for communication? Well, without an agreed set of rules, a few problems are bound to pop up. Messages could be sent in the wrong order, which would make them completely meaningless. The data itself could be misunderstood by the device that receives it, and ultimately, the communication could just fail altogether. The solution to all these problems is something called a protocol. A protocol is simply an agreed set of rules that controls how data is sent, how it's received, and how it's understood. It's crucial that all devices on a network follow the exact same protocol to ensure they can communicate effectively. So protocols are necessary because they provide reliability. They're what makes sure that data gets to the correct device, that it arrives in the correct order, and that it can be properly understood when it gets there. Without protocols, networks just wouldn't work reliably at all. Now, different tasks on a network actually require different protocols. This is all about using the right set of rules for the right job. Think about the common things you do online. Viewing a web page is a very different kind of task from sending an email. And that's also different from, say, transferring a large file. Because these tasks all have different requirements, each one needs its own specific set of rules, or its own protocol. A single set of rules just isn't enough. Let's look at some common internet protocols. Each has a very specific function. For instance, HTTP and HTTPS are the protocols used to access web pages. FTP, which stands for File Transfer Protocol, is designed for transferring files. For email, SMTP is used to send emails, while POP or IMAP are the protocols used to receive them. You see, each protocol is designed specifically for its job. Okay, so we've got all these different protocols for different jobs. How is all of this complexity managed? The solution is to organize the communication process using layers. You see, sending even a simple piece of data across a network involves many different steps. If a system tried to manage all of those steps at once, as one single process, it would be incredibly difficult. And frankly, it would likely be very unreliable. So networks need a structured way to organize all this complexity. And that solution is to split networking into layers. You can think of these as a set of levels sort of stacked on top of each other. Each layer in the stack has a very specific job and focuses on one particular part of the communication process. Using this layered approach gives us several key benefits. First, it makes networks simpler to design because each layer can be developed independently. It also makes it much easier to fix problems. When a fault occurs, it can be isolated to a specific layer. And finally, it ensures compatibility, which allows devices from all different manufacturers to work together seamlessly. So now that we've established the roles of protocols and layers, let's look at how they actually work together in practice out in the real world. A key example you need to know is TCP/IP. It is a layered model, and it's the fundamental framework that the entire internet is built on. It provides the essential structure for how data is sent, received, and organized into these different layers. All right, let's summarize the key points. First, protocols are the agreed rules for communication. Second, different tasks use different protocols. Third, layers are used to organize the whole process of communication. And finally, TCP/IP is the key layered model used by the internet. And to finish, here's a final thought to consolidate your understanding. How do protocols and layers work together to make the internet the reliable global network that it is today?